Welcome to yet another class of system modeling and simulation. Today we're going to look at the newspaper seller problem, where we are trying to find the optimal number of newspapers the news seller has to buy in order to make profit. So let's get on with the video. So let's look at the newspaper seller's problem. So this is a classic inventory problem. Okay, so this concerns with how much newspaper should I purchase or how much should I keep newspapers in stock so that I make a profit and not much of it goes to waste. So that's why it's called a classic inventory problem. And the goal of this problem is to find the optimal number of newspaper the newsstand should purchase in order to make a profit. Right, so let's look at the problem and try to solve it. So the paper seller buys the paper for 33 cents each and sells them for 50 cents each. So this is how much he invests and this is how much he sells it for. Newspapers not sold at the end of the day are sold as scrap for 5 cents each. Newspapers can be purchased in bundles of 10. Thus the paper seller can buy 50, 60 and so on, basically in multiples of 10. There are three types of newsdays that are there. One is good, fair, poor. These indicate how the sale was during that. Was it a good sale, fair or a poor sale, right? With probabilities 0.35, 0.45, 0.20 respectively. So the distribution of papers demanded on each of these days is given. So basically these. The problem is to determine the optimal number of papers the newspaper seller should purchase. This will be accomplished by simulating demands for 10 days and recording profits from sales each day. So we're going to simulate it for 10 days. These are the probabilities given, and the next thing that we have is how much he invested and how much he sold it for. So the distribution of newspaper demand on each day. So when the demand was 40, 50, 60, 70, 80, 90 for good, fair and poor, the probability is associated. So we have these two probabilities that we have to calculate. Random digit for types of news days is this. Random digits for demand was this particular thing. Assume the newsstand buys 70 newspapers each day. So this is how much he keeps in stock in his inventory for each day to sell his newspapers, right? So looking at the problem, now let's look at the solution and how do we actually solve it. So first, like all steps, we calculate the random digit assignment for the type of news days. So there are three types of news days, so that is good, fair and poor. So the probability associated with this is already given in the question, that is this 0.35, 0.45 and 0.20. So we just write that down. We calculate the cumulative probability, so 0.35 remains the same, 0.80 is got by adding these two, 1 is got by adding this. Random digit assignment starts from 0 to 35. Then the next class starts from 36 to 80. Then 81 to whatever is above. So this is done for type of news day. The second table that we need to calculate is the demand and the probability based on the type of news day. So this table, this part of the table is already given here. Right, so what we need to do is all we have to calculate is the cumulative probability for each news day and the random digit associated with it. So we have this table given, this table already given. So good, so this and this is same. 0.08 is calculated by adding 0.5 and 0.3, right? 0.23 is calculated by adding 0.15 and 0.08. Do that for this. Similarly for fair would be 0.1 is same as this. Then 0.28 is got by adding 0.18 plus 0.1. Then we have similarly you calculate for all the fair column and poor. Okay, now we assign the random digit. So 0 to 3 would lie here, then 4 to 8, 9 to 23, 24 to 43 and so on. Okay, similarly for fair and poor, since 1 is there here, we just neglect the last two rows in this column. Similarly the last row in this column. So with this we calculate the two tables, one for the type of newsday and the second is the type of demand and the newsday associated. Next we should look into how do we calculate the profit for each day of the demand that we have. Now coming to the big table where we have to calculate the daily profit and at the end calculate the total profit. So for calculating the profit, there's a formula that's already been given, but let's look at the formula later. Let's look at the table. So we have the 10 days that we have to simulate the simulation for. We have to find the type of news days, the demand it has, the revenue from sales, the lost profit from excess demand. That means excess demand was there but I didn't have enough supply, so that's my lost profit. And then salvage from sale of scrap. If I had a lot of newspaper but I couldn't sell everything, so the scrap that has to be sold comes from this salvage from sale of scrap. And finally calculating the daily profit using this formula. So we have the 10 days. Let's look at how do we fill this column and how I've got fair, good, good and so many other things, right? So for the first thing, this column, these two columns come from the random digits that I have, right? So if we look at the problem, so random digits for type of news days are these 58, 17, 21 and so on. So let's see where 58 lies. So 58 lies type of news day, 58 lies in the range here, so it's a fair day, hence I have fair here. Similarly, the next random digit is 17. 17 lies over here, 0 to 35, so that's good, hence I have good. Similarly, I fill it for all the next 10 customers and I get the type of news days. Now coming to the third column, that is demand. How do we calculate the demand? Again, we look at our random digits. So over here we have random digits 93, 63, 31. So let's look at the first thing, 93. So here it gets a little tricky. Why? Because we have to see 93 and also one thing that we have to look at is that it belongs to fair news day. So while calculating the random digit or while calculating or seeing which class it belongs to, we have to see 93 fair. Okay, so 93 fair. So that would give me in 93, where does 93 lie? Here, fair, and that would be demand would be 80, hence 80. Similarly for good, and the next random digit is 63. So 63 in good, where does it lie? So it lies here. So that would again give me 80, right? So using that, I calculate this column. Again, good, and then the next random digit I have. So using this, I calculate the third column. Now coming to finding the revenue from sales, right? So revenue from sales is basically how much profit I've earned by selling. Now here if you see, the demand is 80. But one thing that you need to remember is in the problem that they have given is that assume the newsstand buys 70 newspaper each day. So 70 is the max limit. Even if the demand was 80, it cannot fulfill. So revenue from sales would be 70 into, it sells at 50 cents. So 0.5, that will give me $35, right? So this would be 35 revenue from sales. Lost profit from excess demand, right? So this is excess demand. Demand was 80, but I had only 70 newspapers to give. So that would be 80 minus 70, 10 into, I could have earned an extra profit of 0.17. How do I get 0.17? 0.17 is basically 50 minus 33. 50 is the cost price, selling price at which I sell the newspaper. 33 is the cost price, right? So 50 minus 33 will give me 17 cents. That is nothing but 0.17 into 10. Why 10? 80 minus 70. 80 was my demand, but I had only 70 newspapers to sell. So that is my lost profit. So 10 into 0.17 gives me 1.7. Salvage from sale of scrap. I didn't have any scrap. Nothing was waste. Everything was sold. So this is nil. Now calculating the daily profit. So I'll just erase this. So now we have to apply the formula, right? So let's see what the formula says. So the first term that comes is revenue from sales. So for the first thing, revenue from sales is 35. So 35 minus cost of newspaper. So cost of newspaper would be 70 into 0.33. 0.33 is the cost price that I get the newspaper. So 70 into 0.33 gives me 23.1, right? Minus lost profit is 1.7 plus 0. This gives me 10.20. So that becomes my daily profit. So I can write that here, 10.20, right? So the next thing that we look at is the second customer or the second day, right? So again, demand was 80. Revenue from sales would again be 35 because I can only give 70 newspapers. Lost profit would again be 10 because I had 70 but the demand was 80, so that would be 1.7. Salvage from scrap, I had no scrap, so nothing. Again applying the same formula, I get 10.20. Then the next thing, demand was 70, so revenue from sales, I have sold everything, so that would be 35. Lost profit from excess demand, there was no excess demand, so nil. Salvage from sale of scrap, nil, nothing. Then applying this formula, okay, one thing that you need to remember is cost of newspaper remains the same. Okay, so this 23.1 remains the same in the entire formula, only these values change. So over here when we apply the formula, we get 11.9. Okay, now this fourth day, with demand being 50, revenue of sales would be 50 into 0.5. Okay, so that would give me 25. Lost profit from excess demand, there was no excess demand. There was salvage from scrap, yes. Why? Because 70 minus 50, that will give me 20. 20 into the 5 cents that I sold it at. So that would just give me $1. So applying this formula, I get 2.90. Similarly, I do it for this and so on, and I fill the entire table, right? So this would be 35, 1.7, nil, 10.20. So finished with all the calculations and I've completed the table. So after completing and filling out all the values, this is how the table looks like. So finally we add up the entire revenue from sales. So when I add this up, I get 305, right? And similarly when I add the lost profit, I get 8.5. When I add this, I get 4.5, and the total profit is 70, right? So my total profit is shown, and hence this is how you calculate the total profit done at the end of 10 days when you simulate it for 10 days. So the newspaper seller problem is solved.